Hi everyone and welcome back to the series the DSA Multiverse. This is the first video in the series where I discuss about the binary search algorithm. So let's dive into it. So the very first question is, what is exactly the binary search? So binary search is nothing but a searching algorithm that is used in limited search space. See, limited search space. So first, let's take one real life example. How are you basically using here the binary search? So I have a dictionary in my hand. It's nothing but Oxford Pocket Dictionary. So dictionary. So okay, dictionary. So it's basically containing certain word in a order. You can say that certain word, or you can say all the words, certain all the word in order. So it's basically starting from A to Z. Now I'm going to searching here a word called bubble. Let's say bubble. So what I basically do as a random user, I just randomly open this book. I just randomly open this book. Now I see that I just randomly open the book and I found a word which is started with D. Now what I basically do, because in our dictionary, it's containing the word basically following the order of alphabet A to Z. So this is nothing but my search space. It's called the search space. Second, taking a red pen, it's called the search space. Now I just randomly open the book D. I mean, open the word which is the first word is nothing but the D. So what I can do, basically searching for the word called bubble. So you know that this is the left portions and this is the right portion. I mean, I'm talking about this. This is the left portion and this is the right portions. So what I can do, I just eliminate this one. I just eliminate this part because it's not needed, because it's not containing the word B. It's not containing the word B. After D, we are not finding any word which is consisting the word called bubble. So what you can do is just eliminate this part, or you can say we can just trim this part, and we just going to search for this part. So what I can do, I'm just searching for this word for this part. See, this how I actually do. I just searching on here and try to find the word. And after that, after few attempts, I found this word bubble in 88 pages, right? I found this word bubble in 88 pages. So this is how we basically use the binary search algorithm in our real life scenario. So you also see one example, the real life example, that here we basically use the binary search. Now, in our binary search, we have the first thing is about the search space. So search space, which is limited. The second thing is our array, because we taking the array in our example, including example, array should be following the shorted manner. Okay, array should be the shorted. See, in our case, A to Z is shorted manner, alphabetically shorted. Same thing in the binary search, we have one search space and our array should be properly shorted. Okay, this is the main things. And what you can do, we just splitting it, right? You can see we just split into two half. Split into half. One is the left part and another one is the right part. And the random choice is nothing but our meat. So I mean, we need some couple of variables, right? So that you can see. Now let's taking one coding example and try to explore it more. Now we don't need this dictionary anymore. Okay. So let's taking one coding examples. So we can say that let's taking one coding example. So let's assume that we have some number. Let's say 1. Let's say 3, 4, 6, 7. Let's say 12, the 16, and the 17. So this is nothing but our array. So it have 0, I mean 1, 2, 3, 4, 5, 6, 7, 8. Okay, it have the 8 numbers. So let's say n is equal to 8. Now if I start in the index number 0, because you know that the array is starting from the 0 index. So it's a 0, 1, 2, 3, 4, 5, 6, and the 7. So this is nothing but our array itself. So how we basically applying the binary search in the array, we need some couple of the variables. So the first variable is nothing but our start. You can take it as a low as well. It's up to you. And here we're taking here the variable called and, or you can take it as a high. And this portion is called the search space. It's called the search space. And our search space is lies between the start to the end. Here we basically do the searching. Now here we're to finding here another variable that's called the mid. I mean the random point. How you randomly actually opening this out? This is called the midpoint. Okay, but we not do it randomly open it in the case of the binary search algorithm. We just need to calculate here the mid. Okay, in this cases. Now let's say we have a target call. Let's say you have a target call. Let's say 5. So you see that the 5 is not available. That means it's not an answer. It's not an answer. We're just searching this one. Now you can see that we're just taking the same example in the case of binary search. Now let's say we don't want to use here the binary search algorithm here. So what we generally do, we just taking here the target and try to match all of them. We try to match all of them. Let's say is it a 5? Is it a 5? Is it 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 5? Or is it 5? If it is not available, just we're returning here the -1. We're just returning here the -1. Now let's say we have a target called, let's say 12. So what we essentially do, this is called a brute force. Okay, this is called a brute force. We basically using here the linear search algorithm. Essentially, we actually using linear search algorithms. So what I can do, we first creating here a for loop and try to iterate to all the value from here and try to match with them target. So our target is 12. So let's say is it 12? Is it 12? Is it 12? Is it 12? Or is it 12? And finally found the value. Okay, we finally found the value. We finally found here our value. That's mean this is nothing but our output. Now let's say we have a target call 17. So what I need to do, I need to just searching the full array. I just need to search the full array, or I need to search the whole array, right? So after that, we finding here our variables. I mean, we finding here our targets. It's mean that we need to searching here the full array to finding here our targets. It's mean that we searching the full array. And this case, our time complexity is nothing but the big O of n. The big O of n. Now we need to also minimize them. So how can you minimize it? We can minimize it using the binary search algorithms. And the time complexity is log base to n. Log base to n. We'll discuss it later on. But let's see first how we basically solving the problem in the case of DSA. We just first thinking of the brute force, and after that we just go for the optimizations ones. So when you're sitting for the interview, make sure that you first thinking of the brute force, and after that you can go for the optimizations. Now when the question is asked by the interviewer, so obviously you first told about the brute force, and after that you told about these ones. Okay, now you can see that in the binary search we have a couple of variables like start, or you can say low, the end, or you can say the high. And this is nothing but our search space. You need to also calculate here a variable called mid. So this is for the binary search algorithm. Now let's see how can we basically solving the problem. So let's try to write down the array again. So it's nothing but the 1, the 3, the 4, the 6, the 7, and then you have the 12, then you have the 16, then you have the 17. Okay. Let's do one dry run. Let's do one dry run. So it's array. So it's from 0, 1, 2, 3, 4, 5, 6, and 7. So this is our start, and this is our end. Now to calculate here the mid. So how can you calculate the mid? So let's say mid is equal to start plus end by 2. Okay. So our start position is nothing but the 0, and our end is 7. So you have the number is nothing but 8, and let's say our target is, let's say 6. We are searching for the number 6. So if I divide it by 2, so it's mean that it's nothing but 3.5, and we can essentially take in the floor value. So it's nothing but 3. It's mean that our 3 index is nothing but our mid value. Now, very first what I can do, we basically match with the target to our meat. Is it the equal or not? So first we match with the meat. I am talking the arrow of the meat to our target. So if it is true, then we just returning here the value, because we finding here our target in our array. Then we returning here the index of that. We return here the index of that, and our index is nothing but our meat itself. Now we see that we basically finding the target called 6. We basically finding the target called 6. So we don't need to move forward them. We don't need to move forward. We just essentially returning the meat. Now what if we just searching here a word called, number called 12. Number called 12, or let's say number called 4. Okay, let's first go for the number called, let's say 7. Okay, first let's say go for 7. Now then after that we go for the 12 as well as 4, and also searching for the no value. Okay, so let's taking the number called 7. Now see that 7 is not equal to 6. 7 is not equal to 6. That's mean the less than, the less than 6, they are not to be equivalent. They are not to be equivalent. So just we trim down the search space. We trim down our search space. So let's clarify it more again. I'm going to taking here this array again. Let's say 1, 3, 4, 6, 7, 12, 16, 17. Now we finding here a meat called 6, and our target is basically the 7. Now this 6 is basically the less than the 7. It's not equal, as well as it's less than 7. That's mean less than 6 is not be considering as my search space, because it's not containing the value, containing the number 7, because our array is shorted. So what we can do, basically we can just remove them. We just can remove them, or you can say we can just stream down it, but we are not deleting it from the array. We just stream down. So what we can do is just stream those portions, and we can just change the position of the start to move ahead of this meat. So our start is coming on here. Our start is coming on here, and our search space is streamed down, and our search space is streamed down, and our 7 is nothing but our start, and our 7 is nothing but a start, and our 17 is nothing but our end. And if I see that our 7, we have the 4, 5, 6, 7, our index number. So let's say this is a 4, this is a 5, this is a 6, and this is the number 7. Now we need to calculate the meat, right? So we need to calculate the meat. So let's say meat equal to 4 plus 7 by 2. It's mean that 11 by 2, 5.5. So index should be the 5. The index should be the 5, right? So this is nothing but our meat right now. This is our meat right now. Now again, I'm searching for that. If it is equivalent to 7, no, it's not equivalent. No, it's not equivalent. So what I can do? We just searching for it. We just searching for it. It's meant that because our value is 12, and our 7, our target is less than the 12. Less than the 12. 12 is nothing but our meat. It's mean that the greater than 12, it's not containing the value 7, because it's greater than 7. So we can trim down our search space. So it's not needed. This part is not needed. So our search space is coming on 7 and 12. So our 4 and 5 is our index. Now we can calculating here a start, our end, it's mean that we need to actually making this end in here. So it should be it's coming on here, it's coming on here, it's coming on here. So meat minus 1, it's mean that our search space is right now in 7. So our 7, we have the start, we have also our end, as well as we have our meat. Now the meat is equal to target. It's mean that we find the value. We finding here our value. I think so. I need to also do it again for another query, so that you can see it clearly and understand clearly, because यहाँ पर थोड़ा गड़बड़ हो चुका है actually. So वो मुझे थोड़ा again करना पड़ेगा बस इसको. So let's taking the blue one. Let's say we have a search, I mean our array 1, 3, let's say 4, 6, let's say 7, the 12, the 16, and the 17. Now fine. Okay. So this is our array. So this is our start point, this is our end point, and our mid is here. This is our mid. Now we are searching for a value called, let's say, target, let's say 16. So our mid is, let's say mid is, so our value is from here, let's say 1, 2, 3, 4, 5, 6, 6, and 7. That's it. So our mid is basically 0 plus 7 by 2 equal to 3.5. So you can take in the 3, I mean integer value, right? So 3. This mean is our mid value. Now our target is basically the 16. Now the mid, if the mid is equal to target or not. So it not satisfy the conditions. And we see that the target is 16, which is greater than the mid. It's when the less than of the 6, it don't contain the end value of the 16. So our now search space is trimmed down, and now we can considering here 7 as our start point. I mean mid plus 1. So you can say that start is equal to mid plus 1. Now our search space is coming on here. That's 7. Then you have the 12, you have the 16, and you have the 17. So this is the 4. So you can say that this is the 4, this is the 5, this is 7, and this is the 7s. Now our mid is the 4 plus 7 by 2 is equal to 11 by 2 is equal to nothing but 5. I mean taking the integer value, or you can say float value. So now our 12 is nothing but our mid value. The 12 is nothing but our mid value. And 7 is our start. And 17 is nothing but our end. And this is our mid. Now our target is basically the 16, right? Our target is the 16. Now our mid is 12 and is not equal to the 16. It's not equal to 16. So the less than 12, it not taking the value. I mean it not represent the value, or it not available in these cases. So you can say that our start should be coming on here. Start should be coming on here. Now our 16 and the 17 is basically our search space. So this is our start and this is our end. Now this is the 6, this is the 7. So our mid is 6 plus 7 by 2. 13 by 2, it means we can considering the 6 as our mid. So this 6 is our mid, and which one is a target itself. Which one is a target itself. So we can basically return it. We can returning here the value. We can returning here the index. Now, what if it not? What if we don't have any kind of value that is searchable? I mean, it doesn't match the targets. So now let's take this example as well, and after that we see the pseudocode and also do the codings, right? So that's a 1, that's a 3, 4, the 6, the 7, then 12, then the 16, and the 17. Now let's say our target is, let's say 9. That's our target. Okay. So same thing, 0, 1, 2, 3, 4, 5, 6, 7. So this is our array, right? Now this is our start, this is our end, and this is our mid. So how can we calculate the mid? So mid equal to 0 plus 7, I mean start plus end by 2. So it's equal to the 3 itself. So 3 is our mid. Now we searching for a value which one's target is nothing but the 9. Okay, let's take in the target as the 9, not actually, because we searching on this part actually. So now let's searching here a value called 5. Okay, let's don't take it. Let's searching for the value called 5. Now our mid is basically the 3 and our value is nothing but the 5. So first we checking here that if the mid value is equal to the target. It should be the array of mid actually. So it's not. Okay, it's when we need to trim down here our source space. Now our target is 5 and our meet is 6. It's mean that our meet is greater. I mean our target is less. That's mean this portion it not contain any value which can have the 5 because the array is shorted. And you can removing this part. I mean you can trim this part. It's not needed. Now our search space is coming here in 4. Now we have the 1, we have the 3, and we have the 4. So this is our search space. Now the start is coming on here. So ant is basically the meet minus 1 in this part. So this is our start, this is our end. Now this is 0, this is the 1, this is the 2. Now we're searching for the value called 5. So let's say our meet is 0 plus 2 by 2. It's equal to 1. It's mean that this position is nothing but our meet. This position is nothing but our meet. So now our value is basically 5. So if I check that 3 is equal to 5 or not, it's not. It don't follow the conditions. It's mean that we need to checking that if the value is greater or the lesser. So our meet is 3 and our target is 5. That's our target. So our target is 5. And our target is 5, it's meant target is greater. It's mean the no value which is less than 5 or less than 3, it not considering, so not 5, less than 3, it not considering as a target. Okay, this portion is also eliminated. Now our search space, our start is go one ahead. Now our 4 is our start, also our end. Now this is nothing but our index number maybe 2, index number 2. Yep, index number 2. Now if I calculate here the meet, so 2 plus 2 by 2 is equal to 2 itself. I mean this is the meet itself. This is the meet itself. Now we're searching for a value called 5. So it's mean that our meet is equal to target. We're just searching for this one. Okay, this should be the array of meet. I just click in meet, but it not the equal. It not the equal. So 4 is not equal to the 5. Now we have to move here our search space. Now because below the 4, it not containing any value of the 5. So we have to move forward them. So our start is go on here. And our start is just passing here this end. It's mean that we have a search spell from start to end. Now a start is go beyond this and it's mean that our condition is false. It's mean that we don't get any output. Then we're returning here the minus 1. Okay, we're returning here the minus 1s. So we see basically 3 example. We basically 3 for 1 example. So you can see 1, 2, and 3 examples. Now let's try to write the pseudocode. And after that, we try to solve this problem using Python and the C++. So let's say we have a function called let's say binary search. So which is taking an array itself, the size as well as the target. So you take, we actually basically need some of the couple of that variables. So you can say that let's say int. Let's say you can say start is equal to the 0, and we also need the end. Let's say n minus 1. And after that, we need to creating here a while loop because into searching it again and again. High enough, the condition is not breakdown. High enough, the condition is not actually breakdown like that. So what you can do, we simply say that while. You can say the while start is less equal to end. We continue our searching. So you can say that the int meet is equal to start plus start plus and minus start by 2. Now the question is why this one? Why this one? When you actually basically calculate the meet, we say that start plus and divided by 2. Now why you basically doing this out? Because of the overflow problem, because of the overflow cases, because we know that in our integer it may be the contain the maximum value of the 10 to the 5 or 10 to the 6 or 10 to the 7. So when you basically to join the two value, let's start is also 10 to the 5 and ant is also, let's say, 10 to the 3. If I join them, the value is exceeding these 10 to the 7s, and when you divide them, try to divide them, we cannot divide it easily. That's why we actually taking these conditions to removing the overflow problems, right? Cool. Now, after that, what I can do, we basically searching for that if the meet is equal to target or not. So we have say that if the meet, okay, it should be the array of meet, the array of the meet is equal to target. So if it is equal to target, we basically returning the index itself. Otherwise, so you can say that else if the array of the meet, we can say that if the array of the meet is less than the target, if the array of the meet is less than target, okay, it is shayad chala gaya, no problems. So if the array is basically the less than target, it's mean that this is a meet and our value is less than the target. Let's say our target is basically 12 and this value is greater, target is greater. It's mean that the no value which is less than the actually the 6, it's not considering as my search space. So you can trim down it. We can trim down it. It's mean that we just taking here a start point, taking here our start point 1 ahead. So you can say that meet plus 1. Otherwise we can say that and is equal to meet minus 1, or you can say that if or else if the array of meet is greater equal to target, it's mean that our search space is streamed down from here. Okay, our search space is streamed down from here. So you can say that and is equal to meet minus 1. So now let's say we can also see one example where we basically don't find any targets. So what we can do basically in this case is we basically checking for that if the start is go over the end. It's mean that if we don't get any value, or if this loop is don't returning any kind of value about the meet, it's mean that we don't get any value, we don't get any kind of target with match. So you can basically returning here the minus 1. We can basically returning here the minus 1. Now this is the full code that you can see. So what about the time complexity? What about the time complexity here? So the time complexity is basically the log base to n. Log base to n. How? Let's see. Now let's say we have a search space which are from 0 to, let's say, 32. Now when we basically taking here 32, we divide here our array. It's mean we divided the 2. It's mean our search space is nothing but 0 to 16. Probably 16, because in some of the cases, if we have the odd or even cases, it may be vary. But we're taking the exact value like that is 16. Now same thing, if I divide this one, we can take in the 8. Same thing for 2, and after that we can take in the 1, 2, and after that we get here the value call 1. We get the value call 1. So this is the 1, this is the 2, this is the 3, this is the 4, this is the 5, and this is 6. It's mean that we have the 6. We basically had the 6th step. Now what if we're taking here that complexity of log 2 base of n. Now in our case, the n is basically the 32. So n is 32. So you can say that the 32 is 2 to the power 5 itself. So now in our n is, we can say that is 2 to the power 5. Now in the case of log base 2, you can just take it in the front. So you can say 5 log 2 2. So 2 base 2. It's been high and the value is 2 base 2 is equal to, I mean, log of a or a, it's nothing but the 1. I mean, this is the equation. Log a by a is equal to 1. So you can say that 5 cross 1 is equal to 5, which one is approximately the same as the 6, near to 6, near to 6. That's why the time complexity of the binary search algorithm is log to base of n. Here the n is nothing but our search space itself. That's the main thing. That's the high level intuitions, right? Now what you can do, we're just going to go on the code and try to solve it. Okay. So there was pseudo code. So you can go on here in the lead code. And now let's try to solving this out. First, let's try to solving this out in the C++, and after that, you're solving this out in the Pythons. So what I can do is taking here some of the variables. Let's say int start is equal to 0, and I can say that int the end is equal to the nums dot size minus 1. And after that, we're taking here a while loop. Let's say while start end. And then we're calculating the meet. Let's say meet is equal to start plus end minus start by 2. Okay. Then after that, what I can do, we basically, okay, we need to go on here. So meet is equal to target or not. Okay, we can say that if the nums of the meet is equal to target or not. If it is at equal to target, we just simply going to return it. Okay, let's say you can simply returning the meet, and else if it is again chalaya, else if the nums of meet is less equal to target. Okay, you can say that if it is less equal to target, and then you can say the start equal to meet plus 1. So you can say that start is equal to meet plus 1, right? Now else we can say that the end is equal to meet minus 1. And after that, we can simply going to, if we don't find anything else, we're just returning here the minus 1s. Okay. Now we can running this out and try testing it out, right? So let's see this one. You can see accepted. Now we can submit it. Okay, you can see the submitted. Cool. Now let's do it using Python. Let's go on the Python 3. So this is this one. So we can taking here, we don't need to taking here any kind of actually the data type in Pythons. So you can taking just like the, so we have the start. Let's say start is equal to 0 and end equal to length of the numbers minus 1. Okay, you don't need to give it here the semicolon here. Okay, so you can say that while the start is equal to end, so we're taking the meet equal to 0 itself, otherwise we may got some error. So you can say that the meet is equal to start plus end minus end minus start by 2. Okay, and then if the nums of meet is equal to the target, then we return here the meet itself. So if the nums of the meet is less than the target itself, so we can say that the start is equal to meet plus 1. Okay, can also take it on here, this portion like that, and otherwise we can say that the else, we can say that the end equal to meet minus 1. Okay, so after the while loop we can basically returning here the minus 1s. Okay, Now let's check in this out. We got any error or not? I hope so it executed. You can see that accepted. Now you can submit this out as well. Okay. Okay, you can see it also accepted in the Pythons. So see the code in C++ as well as the Python's programming language. Cool. Okay, if you have any kind of confusion, you can comment below. And in the next tutorial, we start to see the examples about the, you see the next topic about the upper bound and the lower bound. So that's it for today now. I hope you enjoyed this full tutorial and as well as this series. And make sure to subscribe to the channel as well as share with your friends. Thank you and bye-bye. Namaste. Bye-bye.